Solve the system of equations by elimination. In order to solve a system of equations by elimination, you need to line everything up. I'm not even close. So what I'm going to do is I'm going to put both of these in standard form. I'm going to have x, y equals number. So let's start off with this guy. I'll label you black. 3 plus 2x minus y equals 0. In order to get you to standard form, I'm going to subtract 3 from both sides. Minus 3 minus 3. Drop down to 2x minus y equals negative 3. So now you're in standard form. Let's do this guy. Negative 3 minus 7y equals 10x. Watch what I do. I want this to be something x, something y equals a number. I don't want to move too much. I'm going to add 7y to both sides. And you might be like, no, 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 sir, that's going to be backwards. Watch. Negative 3 equals 10x plus 7y can also be written as 10x plus 7y equals negative 3. Pretty smart, huh? Now that I have everything lined up, I need to eliminate. Well, I can't, because 2x and 10x are not the same but opposite, and negative y and 7y are not the same but opposite. So let's get rid of x, and we'll multiply the top row by negative 5. By multiplying the top row by negative 5, and let me write it out here to the left, I'm going to end up with negative 10x plus 5y equals 15. The bottom equation stays the same. 10x plus 7y equals negative 3. If you're wondering, why didn't you just multiply the top by 7 to get rid of the y's? I could have, but I didn't. So I'm going to add these two rows up. I'm going to add them up. That crosses out. This becomes 12y, and this becomes 12. Divide both sides by 12. Divide both sides by 12. And y is going to equal 1. Now you know y is 1. I have these two original equations. I'm going to pick one of my original equations and solve for x by plugging in 1. So why don't I use the bottom equation? To me, it looks less sloppy. If I use the bottom equation, it would be negative 3 minus 7 times 1, because y becomes 1, equals 10x. Okay, negative 7 times 1 is negative 7, so negative 3 minus 7 equals 10x. Negative 3 minus 7 is negative 10 equals 10x. Divide both sides by 10, and x equals negative 1. Now that x is negative 1 and y is positive 1, I have an ordered pair of negative 1, 1. And what that means is if I take negative 1 and plug it into every x here, and take 1 and plug it into every y here, I would have two things that would match up perfectly. So this problem was a mess, but we rearranged it, we did a little bit of multiplication, and we did fine in the end.